Imagine a powerful giant, like the Sun, clashing with a tiny yet mighty opponent, a small black hole. The collision is imminent, and the fate of the solar system hangs in the balance. Will the Sun be able to withstand the intense gravitational pull of a tiny black hole, or will it be swallowed whole? The answer lies in the forces at play in this mind-blowing cosmic collision, so let's break them down. First of all, what is a black hole? A black hole is a region of space where the gravity is so strong that nothing, not even light, can escape from it. Like a cosmic vacuum cleaner, it sucks up anything that gets too close. It's so massive that it warps the fabric of space-time around it. Black holes are one of the most scary and mysterious objects in the universe, a powerful force of nature that defies our understanding of physics, a true enigma of the universe. Black holes come in different sizes, from small ones that are only a few miles wide, to supermassive ones that are billions of times the mass of the Sun. Most of them are formed by the collapse of massive stars. After the black hole is born, it starts to grow in size by eating everything in its path. And if two or more black holes collide with each other, they can merge into one enormous cosmic monster in a terrifying dance. But what about the smaller ones? The smallest known black holes are called stellar black holes. It's a type of black hole that weighs 3 to 10 masses of our Sun, while being very small. It's like taking all the matter in the solar system and squeezing it into something the size of New York City. And yes, it's considered very small. Just for comparison, intermediate mass black holes weigh between 100 to 1,000 solar masses, and supermassive black holes weigh millions or billions of solar masses while being unimaginably huge in size. So, stellar black holes are basically nothing compared to their relatives. Imagine a massive star, bigger than our own Sun and with a heart made of nuclear fuel, burning bright and hot. But as the star runs out of fuel, gravity takes over and starts to squeeze the star. The more it squeezes, the hotter it gets, until the star's core reaches a temperature of billions of degrees. Eventually, the core collapses under its own gravity. This creates a massive blast called a supernova. This collapse creates a singularity, which means a point of infinite density and gravity. This point is surrounded by an event horizon, the invisible line beyond which nothing, including light, can escape. And just like that, voila! A stellar black hole is born. Pretty mind-blowing, isn't it? Stellar black holes are the most common type of black holes we know of. These guys can be found all across our galaxy. So, what are the chances that such a little monster will come for our Sun? And in that case, what will happen to us? Well, actually, the likelihood of the Sun colliding with any black hole is incredibly small. It's almost impossible for it to happen. Even though stellar black holes are the most common type of black holes in our universe, they aren't common at all. The chances of the Sun and some black hole crossing paths is so rare, it's basically like winning the intergalactic lottery. Only this win wouldn't be that pleasant. For 2023, the closest known black hole in our solar system is Gaia BH1. It's about 10 times heavier than our Sun, and even this one is about 1,600 light-years away from us, which is a quadrillion miles. So, it's safe to say that our Sun is not going anywhere anytime soon. But never say never, right? Just like with any astronomical event, we need to understand the different ways something like this could happen. For example, it would be possible if a rogue black hole passed through our solar system, much like a comet or asteroid passing by. Unfortunately, unlike comets and asteroids, black holes are invisible and can only be detected by their gravitational pull. So it's not like we'd see a big, ominous black hole hurtling towards us. Rather, we'd only know it was there if it caused some sort of disturbance in the orbits of nearby objects. So what now? We know that the Sun is a massive, luminous star at the center of our solar system. It's about 4.5 billion years old and has enough fuel to last for another 5 billion years. This star is so big that it's hard to even comprehend its size. In fact, if you were to put all the planets in our solar system inside of it, there would still be room for more. And it's so massive that it contains almost 100% of the total mass of the solar system. So it's hard to imagine how some insignificant small black hole thousands of times smaller than this star can devour it. And you're right, it won't. Well, at least not completely. So imagine if a rogue black hole arrived in our solar system and has begun to approach the sun. As it gets closer and closer, the black hole's immense gravity will start to pull the material from the surface of the sun. The sun would start to get stretched and distorted. This is called spaghettification. Imagine a rubber band being stretched until it snaps. That's kind of what would happen to it. This gathered material will form a swirling disk around the black hole, called an accretion disk. As more and more material is pulled in, the disk will heat up and start emitting intense radiation. And as the sun gets pulled in, it would start to release massive amounts of energy in the form of light and heat. The sun would become much brighter and hotter than before. The sun's outer layers would be vaporized, creating a massive cloud of gas and dust that would expand outwards. It would be like a cosmic fireworks show, but with terrible consequences. Even though it would be one of the most spectacular views in the universe, we wouldn't be able to see it. As you might have guessed, the Earth would be in for a really rough time. The intense radiation and solar material would cause massive wildfires, and the intense heat would vaporize the oceans. The Earth would be bathed in a constant stream of high-energy particles, and the atmosphere would be ionized. In short, the chances of any life surviving would be close to zero. And this collision would have far-reaching consequences not only for the Earth, but for the entire solar system. The intense radiation and heat would vaporize everything in its path. All the planets would be destroyed. Now, the sun being a larger object than a typical star wouldn't be completely devoured by the black hole, but it would be significantly distorted and disrupted. The intense gravity of the black hole would cause the sun's outer layers to be pulled away, creating a massive blast called a tidal disruption event. But either way, in the end, the black hole would win. It would grow in size, and a new accretion disk would form around it. As we've seen, the collision of the sun with a black hole, whether it be a tiny or stellar one, would be an epic and catastrophic event. But thankfully, as we've already mentioned, the likelihood of such a collision happening is extremely low. However, that doesn't mean we should stop studying black holes and their potential impact on the universe. The more we learn about these mysterious objects, the better equipped we'll be to understand and predict their behavior. So, let's keep researching, exploring, and observing the depths of space. And who knows, maybe one day we'll come across a black hole that's just too curious and gets too close to the sun. Let's hope by that time, we will already be living on other distant planets.
If the sun decided to stop producing light, then the animals in the wild would be the first to notice. Most animals need daytime to roam from place to place, especially in the large savannas in Africa. Zebras, wildebeests, and giraffes all need the day to move to avoid predators. As soon as the sun goes down, it's their bedtime. If the sun suddenly went dark, animals wouldn't comprehend what was going on and would simply become an early lunch for predators. Nocturnal creatures would be equally confused at the time change. Birds usually flock during the day, so we wouldn't hear or see any of them. We have them to thank for eating pests in the sky. Well, them and bats. But if you're in an area with no bats, then consider the insects to be the winners here. Temperatures would start to drop gradually. Humans would notice the effects as well. We're used to having the sun shining at the peak of noon. But with the sunshine's disappearance, we would be living in total darkness. It'd just be a matter of survival. If the sun suddenly got dark, then we'd only have around 8 minutes to enjoy the rest of it. That's because it takes that much time for sunlight to travel thousands of miles across the solar system. We would have to use UV lights to grow some crops, but it wouldn't be enough to feed the whole world, not to mention the dropping temperatures across the world. Survival would be difficult in the open plain. Everyone would have to duck inside shelters and warm bunkers. Plants need photosynthesis to grow. Without it, we wouldn't have any crops. Bread wouldn't exist, since it needs wheat. Even the algae in the oceans need photosynthesis to survive. which is the highest source of oxygen rather than forests. This means oxygen levels would start to deplete. Large bodies of water like lakes, oceans, and seas would also start to lack oxygen to sustain marine life. One of our main sources of vitamin D is the sun. There are other ways of getting it, but the sun is the best and most convenient way. Without crops or vegetation, all the herbivores would have to rummage for the last green grass on land or a leaf hanging from a tree. They would soon run out of food, which would also be bad news for us humans, since we need animals like cows, horses, and sheep for our livelihoods. This wouldn't happen overnight. Of course, the oceans would remain warm for some time, but eventually, they would get cold and freeze. Earth is still a planet powered by an iron core that produces so much heat. This would not be enough to keep the planet warm. Our next step would be finding the right shelter and keeping warm. If this happened overnight, then chances are there wouldn't be any ready-made bunkers for a scenario like this, unless you're watching this video and decide to build one after. They would have to provide heat 24/7 and be capable of growing crops under UV light. Solar-powered facilities would be a thing of the past. People would have to wear sustainable suits when venturing out into the open. Since it would be so dark, we would need strong lights or powerful night vision goggles to see anything. The lands would be desolate. Nocturnal creatures that can handle freezing temperatures would take it over. Structures would collapse, since there would be oxygen depletion. Concrete needs oxygen to remain intact. The bunkers themselves would have limited oxygen as well. We would need to uproot many trees and place them under strong UV lights for them to produce oxygen. In turn, it would produce its ecosystem in the large underground bunkers. The oceans on the surface would freeze over eventually. Gathering any natural resources from the ocean floor, like gas or oil, would be impossible. The large object, which used to be a bright and sunny star, would still be floating around. But what would happen if the sun disappeared overnight? Well, pretty much the same thing, except way worse. The sun is the largest celestial object in our solar system, which keeps all of our planets lined up the way they are. They orbit around the sun, minding their own business. Without such a large object keeping them steady, the planets would start to float around randomly. Some might even collide with each other. In other cases, the planets would just float around and fly off into space eventually, until they found a new star to orbit around. Earth might or might not be one of those planets. Our planet would still be dark. We would be flying through space at an unusual speed. The planet wouldn't rotate on itself, and many objects would crash into us. We'd be in the trajectory line of mass comets waiting to strike us down. The threat of the cold wouldn't be a major factor anymore. It would be what's beyond us. This means we'd have to dig our bunkers deeper. We wouldn't have an atmosphere anymore to trap any form of heat or anything. We would be floating for an eternity. But let's go back to that scenario where the sun just decided to go dark. Don't worry, our planet would still be orbiting the sun along with the other planets. The temperatures would keep plummeting until nothing could survive on the surface. It would be total darkness 24/7. Only bacteria and possibly tardigrades could survive on the surface. Tardigrades are microscopic critters that can survive just about anything, including outer space. Eventually, oxygen would be absent from the Earth's surface, and there wouldn't be anything up there anymore, except for them. Since they would be the dominant and possibly the only creatures on the surface, they'd manage to evolve into bigger species and produce many more. Hundreds of thousands of years into the future, humans would have had to evolve to the conditions underground. Our eyes would be much bigger to take up as much light as possible. Our skin would become whiter since there would be no sun underground. Our hearing would also be much more sensitive since the underground would create echoing sounds. We'd still have the intellect we do now, but our bodies would be ready for the surface. The main threat would be the giant tardigrades sluggishly dragging themselves around. Under a microscope, they look kind of cute, but imagine them the size of a polar bear. Still want something like this in your backyard? They can live anywhere, so they'd infiltrate the bunkers now and then. They'd get ferocious and come in different sizes and shapes. At this point, Humans would not be the dominant species, since they'd have to hide underground. Some tardigrades from different tribes wouldn't be friendly with each other. Major cities that used to be bustling with people would be home to giant water bears. Tardigrades are known as water bears since they kinda look like little bears, but these beasts with 8 legs would be much bigger than them. Bears and most animals would have been wiped out on the surface. Under the ice, some deep-sea creatures would thrive and have moved closer to the surface. These animals were used to living in darkness away from the sun, but over thousands of years of dominating the waters, they'd have grown to enormous sizes. Some of these creatures would adapt to crawling out of the mainland. Even though the surface would be frozen, they'd still find ways to crack through the ice and make their way. Humans, meanwhile, would create large underground channels and networks, building cities and colonies. We'd dominate the tunnels where our hands and feet would grow to become web-like and large. We'd take over everything underground and remain the smartest species on Earth. We'd manage to keep old art pieces from the surface and important records to stay as human as possible. We'd keep on surviving no matter what.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical? Or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
You already know about black holes, giant space vacuums that pull inside everything in their way. But have you ever heard of a space phenomenon called white holes? And what would happen if these two met and, let's say, collided? Let's hop on a shuttle, venture into space, and get to know them better first. As you already know, you can't see black holes directly.
even with fancy telescopes that detect light, X-rays, or other types of electromagnetic radiation. But we can see what a black hole does to the things that surround it. For example, when a black hole passes through a cloud of space matter, it pulls everything towards itself in a process called accretion. As the matter is pulled in, it becomes hot and emits detectable X-rays. Or something else can happen. Sometimes a regular star comes too close to a black hole and gets torn apart. A black hole is a super dense object with an incredibly strong gravitational pull that starts stretching the poor star out into a long and thin shape like spaghetti. You've probably guessed it, we call this spaghettification. As the pieces of the star are pulled in, they become hot and emit X-rays. A black hole can choose a different method too, squishing the star and making it flat like a pancake. In the other corner, you have a mysterious white hole. These are less well known because we don't have much information about them. Our knowledge of white holes is based on theories derived from the same mathematical equations used to describe black holes. To witness this battle, you would need to get close to a white hole. But don't worry, at least this one won't eat you and turn you into spaghetti or a pancake. Just like nothing can escape a black hole, nothing can enter a white hole. It's like the most exclusive club in space with no entry allowed. You can see that white hole also has a mass and even spin. There might be a ring of dust and gas around its outer edge, known as the event horizon, which acts as a border separating the white hole from the rest of the universe. While they share similarities, there's one crucial difference. A white hole can release matter and energy, while a black hole cannot. Scientists describe a white hole as the time reversal of a black hole, as if you're watching a video of a black hole played backwards. Things that are already inside a white hole can leave and interact with the outside world. However, nothing from outside space can ever affect the secretive inner world of a white hole. Einstein said that space and time are not flat. They can bend and fold. All because things like stars and planets have mass. A scientist named Carl Schwarzschild figured out how to use Einstein's ideas to describe what happens around a really heavy object. He discovered something called a singularity. It's a point of infinite density, and it lies at the center of a black hole. It's like a tiny, tiny point where everything is squished together, all the matter that the black hole has consumed. The tricky part is that the singularity is so small that it doesn't really make sense in our normal understanding of time and space. Plus, it bends space around it so much that it creates a special area that's cut off from the rest of the universe. We call this area a no man's land, which is basically where black holes exist. Scientists still can't understand what happens at the point of singularity in black holes, let alone white holes. So let's go back to the questions we started the story with. What's stronger, and what would win then? It seems black and white holes have completely different strategies. A white hole is a mystery that we still don't know much about, but it seems more experienced at conquering space than a black hole is. I mean, a black hole swallows matter and everything it encounters, true. But a theory suggests that white holes may have once been black holes. They're purely imaginary for now, but stories say white holes can only exist if there is absolutely no matter inside their boundaries. If even the smallest particle entered a white hole, it would cause it to collapse. That's a significant disadvantage in a potential battle, don't you think? But it's also a really tough task to try to sneak a small asteroid inside a white hole. Its gravity is most likely extremely powerful and will push you away. This is where the singularity comes into play. Remember when I said scientists were not sure what really happens with this tiny, tiny dot of infinite density? It can't be that a black hole just infinitely collects matter in its center. Something else has to be happening there. What if this singularity kind of rebounds and actually becomes a white hole? Of course, it would take a really long time for this to happen, like billions of years, even for the smallest black holes. There's a special type called primordial black holes, and scientists think those probably formed right after the universe was born. And if there were really tiny black holes created after the Big Bang, they might have already exploded and turned into white holes. Some scientists even think white holes could possibly explain the Big Bang, since both involve an enormous amount of matter and energy appearing out of nowhere. All this doesn't sound promising for a black hole. Can this be the first time ever it's gonna lose? If a black hole becomes a white hole, it doesn't even matter how much it's consumed. It might throw everything back out into space. In that case, a white hole might not last that long, so it will need to make a move against its opponent really quickly. Whoa, you may have thought you were safer near the white hole because it wasn't about to eat you. But look at it! It's shaking! Oh no, it started ejecting all the things it's been keeping inside at the speed of light. Get out of the way to not have some ripped planet catapulted in your direction. After millions, even billions of years of making a mess all around the universe, a magnificent, spectacular, and chaotic battle is about to start. The black hole is patiently taking the attack, pulling in everything that the white hole is throwing in its direction. Asteroids, all those ripped stars that used to shine so brightly in the night sky, planets, and even entire galaxies, it's all getting out of it insanely fast and in all directions. Both the white and black hole have managed to survive against every space object till now, but that's just because they haven't faced each other yet. It's an exhausting battle that doesn't stop. All odds were against the black hole at the beginning. But look, it seems something is changing. The white hole is slowly losing energy since it can't swallow any new things and renew its supplies. Meanwhile, the black hole is patiently collecting everything its opponent has thrown at it during this fierce attack, growing bigger and bigger. It can keep doing it for thousands of years. Its insanely strong gravity brings the white hole closer, even though it's trying to escape. And the time comes for the last strike. The black hole's gravity starts stretching its enemy until it swallows it entirely. The white hole is completely gone, and now that it has so much energy, our winner is more massive and stronger than ever. Oh no! Run! Now you have this hungry supermassive black hole wandering around looking for more things to eat. Until it falls apart into a white hole again one day and starts an even bigger, more magnificent battle that the entire universe will watch.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So, people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between two colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them, but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of hundred years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller, but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there. Consider the rogue planet, the cosmic wanderer that nobody wants to take home. Basically, a rogue planet is a planet that has been ejected from its own star system and is now floating aimlessly through space like a cosmic loner. These planets aren't just a theory. Scientists have actually detected some in our galaxy. In fact, estimates suggest that there may be lots of these cosmic nomads floating around the Milky Way. And they aren't just small rocky worlds like Earth. Some of them are actually massive gas giants, many times larger than Jupiter. These behemoths could potentially have their own moons, and even their own mini-systems orbiting around them. For example, one of the most famous rogue planets we know of has a complicated name. Here, you read it for yourself. It's located about 80 light-years away from Earth, and it was discovered in 2013. This rogue planet is estimated to be around 6 times the mass of Jupiter, and is believed to be around 12 million years old. And yes, just because these cosmic loners don't have a star, it doesn't mean they're super cold. They can still generate heat and light from their own internal processes. Some may even have magnetic fields and auroras, just like Earth. In other words, rogue planets could potentially be habitable if they have the right conditions. So, what would life on such a planet look like? And could we potentially live in such a world? Well, living on a rogue planet can be a lonely existence. They have no warm sun to bask in, no cozy atmosphere to cuddle up in, and no cosmic neighbors to have barbecue with. That's why we'd have to get creative. Let's start with the most obvious problem. We'd have a hard time without light and heat. So, how do we fix this? Well, we'd probably have to invest in some really fancy space heaters and wear fashionable super-warm spacesuits. Or we could invent a whole new way to generate electricity without relying on solar power. For example, how about using geothermal energy? Now that's hot stuff. Each planet has an internal source of heat. Without it, they would all be nothing more than cold, lifeless rocks floating through space. This internal heat can be harnessed and used to power everything, from homes to factories to spaceships. It's like having a hot tub big enough to power an entire city. And that city, most likely, will be located underground, closer to the heat source. And as for light, well, Well, we'd probably have to build some really bright flashlights. Or maybe even learn to genetically engineer some bioluminescent organisms to light up our homes. Just imagine, space is overgrown with neon mushrooms and plants. By the way, speaking of plants, plant life would be pretty hard to come by without a star. So, what would we eat? Well, we could use the same geothermal vents that we talked about, or some chemical reactions to sustain ourselves. And hey, maybe we'd develop a taste for sulfur-rich foods, or we'd start fermenting our own drinks from the bubbling volcanic mud. Yum! But besides food, we'd have a more important problem. Living on a rogue planet would be breathtaking, literally. We'd have no air. You see, not all rogue planets have good, stable atmospheres. It all depends on their size, composition, and other things. But even if our new home does have an atmosphere, it may be incredibly thin and unstable. We'd have no pretty blue skies or dramatic sunsets to admire. Instead, we'd be staring out into the infinite void of space, where the stars would be brighter than ever before. And forget about weather patterns. Without an atmosphere to create them, we'd have no rain, no snow, and no thunderstorms. And that's just some minor problems. What's worse, the temperature on the planet would be wildly fluctuating, swinging from unbearable heat to unbearable cold. It would be like living in an oven that's always being turned on and off. And finally, we'd be exposed to all kinds of space debris and cosmic radiation. So, if you don't want to get crispy, you might want to invest in some serious SPF. So, how do we fix it? Well, we'd have to find a way to generate our own oxygen and probably create something like a space-age biosphere. For example, we could grow some plants that could produce oxygen, or we'd learn to filter the air like a high-tech air purifier. Finally, we have the last most important problem, finding water. And here's where the underwater oceans come to our aid. Now we're really diving deep into the possibilities. Nyuk nyuk. But seriously, scientists suggest that some of these planets may indeed have underwater oceans. It would be like living on a giant water balloon that's been buried underground, with the ground beneath your feet made of ice and rock. In other words, we could just tap into these underground oceans. They could provide us with a source of water for drinking, farming, and manufacturing. Maybe even with some other resources and materials we've never seen before. And by the way, who knows what kind of strange creatures might be lurking in those underground seas? But don't worry, even if we don't have any underground oasis, there are also other options. We could get some water from comets, ice mining, and even from the atmosphere, the one we just created before. Finally, we need to find and mine some resources to build our homes and other stuff. And a rogue planet might not have the same kinds of resources as a planet that orbits a star. It's like trying to find some treasures in a desert, not exactly a sure thing. We may have to rely on resources from nearby asteroids and things like that. And if we want to extract resources from the planet itself, we might need to drill down through miles of ice and rock. But hey, if you're up for the challenge, there'll always be a chance you'll strike it rich on a rogue planet. And who knows, maybe you'll discover some new resources that are even more valuable than gold or diamonds. Great! Looks like we've solved the most important problems. Now, there may be other small difficulties. For example, we'd also have to deal with some seriously long days and nights, depending on how fast our planet was rotating. And we wouldn't have a normal, regular day-night cycle. The rotation of our planet could be wildly unpredictable. Maybe we'd have weeks-long nights, followed by weeks-long days, which could really mess with our sleep schedules. We might have to develop some really strong coffee to keep us going through those long, dark nights. But, hypothetically, we can adapt to all these things and overcome all the challenges. And now, finally, welcome to the rogue planet, where the sun never rises, but the adventures never end. Thanks to our advanced technology, we've managed to create a comfortable and habitable environment in this once barren world. The sky above us is now a beautiful shade of blue, filled with fluffy white clouds and the occasional flock of flying creatures. Don't ask. As we venture out from our underground habitats, we're greeted by a world that's full of surprises. Strange plants and animals have adapted to the unique conditions of this planet, some with bioluminescent features that glow in the dark. And be careful if you want to go swimming in the underground ocean. They might be home to some bizarre creatures who want to feast on, well, we'll come back to that. Maybe. As you can see, we've created sprawling cities and thriving communities, powered by the planet's geothermal energy. We also created a bunch of artificial light sources that keep things bright throughout the dark, chilly nights. Of course, we still have some problems with navigation and timekeeping, but things aren't as dull as they used to be, are they? Overall, living on a rogue planet would definitely have its challenges, but it could also be a pretty exciting way to experience the universe. And who knows? Maybe someday we'll find such a planet and actually turn it into a bustling intergalactic metropolis someday. But until then, let's enjoy and tidy up our dear Earth.
What if we lived in a world where the moon and the sun swapped places? Yeah, I know what you're thinking. The consequences would be staggering and catastrophic. But here's an interesting take. What if we somehow survived all this? What would our life look like in such a new world? And what would happen to the solar system? Time to find out. Let's start with the moon. Did you know that the moon is responsible for the tides on Earth? You know, that thing where the ocean goes in and out like it's playing a game of beach volleyball? All thanks to our satellite's gravitational pull. The moon also helps stabilize Earth's rotation. It's pretty important if you don't want to end up like a certain planet that spins on its side. Looking at you, Uranus. Plus, it acts as a shield, protecting us from some of the more harmful cosmic rays, asteroids, and space debris. It's like our personal bodyguard. And without our satellite, we might not be here cracking jokes and enjoying life at all. Some scientists think that the moon played a crucial role in the development of life on Earth. Without its gravitational pull, we could have a crazily erratic climate. Also, the moon could have redistributed water across our planet, and we all know that water means life. As for the sun, we all know how important it is. It provides light, heat, and energy for all the planets. But, just like any good party host, the sun can get sometimes a little too intense. Never forget that it's an extremely powerful and massive star, with a surface temperature of about 10,000 degrees Fahrenheit. If it wasn't for our ozone layer, we would all get burned instantly. The distance between the Earth and the Sun is about 93 million miles. Scientists took this distance and turned it into a unit of measurement, 1 astronomical unit, or AU. The closest distance that the Earth could approach the Sun without being completely destroyed is about 0.9 AU. At the same time, if we move too far, further than about 1.2 AU, our planet will turn into a snowball. So we got pretty lucky with our location. Meanwhile, the distance between Earth and the Moon is about 0.002 AU, or 240,000 miles. It's super close to us. Now that we know how important these two are, and how much their position affects our world, let's try to swap them. Surely nothing bad will come of it. First, let's imagine for a moment that the Sun was in the Moon's place. You probably already know what will happen to us. The intense heat and radiation from the Sun would be like the world's worst sauna, with the temperature on Earth rising rapidly. Any living thing on Earth would leave behind nothing but a pile of ashes. But the destruction wouldn't stop there. The atmosphere and oceans would be stripped away by the solar wind, leaving the planet exposed and vulnerable to the radiation and particles coming from the Sun. It would be like a giant space hairdryer on full blast, with Earth's atmosphere and oceans being blown away instantly. Forget about melting ice caps. The entire planet would be one big puddle. But that was a scientifically accurate answer. Boo, boring. Now, what if we could somehow survive this catastrophe? Like, what if we had some super advanced technology to protect us from being fried to a crisp? First up, even if our planet somehow survived, things would still get pretty toasty. since the sun would still emit way more heat and energy than the moon. Also, unlike the moon, which goes through periods of darkness during its lunar night, the sun has a constant energy source through nuclear fusion. So at least we wouldn't have to worry about freezing every night. We'd just be sweating buckets in our sleep. Of course, all this extra heat would have some serious effects on our ecosystems. Plants and animals would have to adapt to survive. And we might see some major changes in the way life on Earth operates. Imagine the confusion of nocturnal animals. Without the moon, they would have no idea how to navigate or hunt. So, what would we do in this new, super hot world? Well, maybe we could build some seriously high-tech greenhouses to trap all this heat. Or we could use some giant mirrors or other reflective surfaces to manipulate the amount of sunlight that Earth receives. Next, we have the sun's gravity. Remember how we said that the moon's gravitational pull is just right for stabilizing Earth's orbit? So, if we replace it with an entire star, things would get pretty wacky. We're talking about extreme changes in seasons, climate, and all sorts of weather-related shenanigans. Your everyday life would look like it's trying to do the cha-cha slide during an earthquake. The Earth's rotation would also speed up drastically. This means shorter days, longer nights, and lots of confusion with working hours and birthdays. So, is there any way to fix this? Well, hypothetically, we could use some massive spacecraft or other technologies to artificially adjust Earth's orbit and rotation. For example, we could launch rockets or space tugs that would slowly push our planet into a new orbit that's more stable and consistent. And that's not all. All this gravity play would also mean new tidal waves of epic proportions. We're talking waves so high that surfers would need oxygen tanks just to catch a ride. Imagine trying to sail a boat through a hurricane while riding a bucking bronco. Yeah, yeehaw! The moon also mixes up nutrients in the ocean and helps support marine life. So if we swap the sun for the moon, those nutrient-rich waters would be a thing of the past. The ocean would become a stagnant, lifeless soup, with nothing but algae and plankton to keep us company. We'd have to resort to eating seaweed sandwiches and drinking desalinated water just to survive. And let's be real, nobody wants to live in a world without sushi. So what do? Well, we could try to somehow artificially create tides or mimic the moon's gravitational pull on the ocean. Like using pumps or other mechanisms to move large volumes of water around in a way that creates a similar tidal effect. Or we could try to help marine life to adapt to the new, less nutrient-rich ocean. Maybe developing fish farming or aquaculture. Finally, don't forget about radiation. The sun is basically a radiation factory. It could seriously mess with our health and electronic devices. You think your phone is fragile now? Imagine what would happen with it under a giant solar flare. So we'd need some seriously advanced shielding technology to protect us. We're talking materials that can withstand temperatures hotter than a jalapeño's backside, and magnetic fields powerful enough to deflect charged particles. Oh, and tons of sunscreen. In summary, if we replace the moon with the sun and somehow manage to avoid catastrophic consequences, it would be a completely different world than what we know. But it wouldn't just be the Earth that would feel these effects. So what would happen to the rest of our solar system? For starters, if the sun with its crazy gravitational pull took the moon's place, it would start seriously messing with the other planets' orbits. They might be sent careening off in random directions, like bumper cars. The planets would also have some taste of the sun's fiery personality. They would have to deal with all the radiation and charged particles. Lastly, the sun's magnetic field is incredibly strong, and if it took the moon's place, the other planets would be forced to dance to its tune. This could cause electrical storms, auroras, and other crazy electrical effects everywhere. And what would happen to the moon itself? Unfortunately, its reign in the center of our solar system won't last too long. Most likely, it will either start orbiting the sun and be eaten by it, or simply fly away like a free bird. So there you have it, a cosmic prank gone horribly wrong. What can we say? Let's just be thankful that such a scenario isn't physically possible, and instead enjoy the beautiful moon and the life-giving sun from a safe and comfortable distance.